The Milky Way is a tremendous structure in space containing billions of stars and trillions of planets. In their turn, these objects are surrounded by gigantic clouds of interstellar dust and scorching hot gas streams. All these components make up the bizarre and fascinating picture called galaxy. And today, we invite you on an exciting journey across it. For understanding early evolutionary stages of stars. As we've seen, not every star has a planetary system, so our next stop is near the orange dwarf Gliese 370, 37 light-years from Earth. In 2011, a single exoplanet was discovered near it, designated Gliese 370b. The object was discovered with the use of the radial velocity method and has a mass of 3 to 4 Earths. According to current understanding of the formation of celestial bodies, the discovered world is most likely a rocky planet, with a radius about 30% larger than the Earth's. Under such conditions, the gravity on its surface may be at least 40% higher than what we're used to. Gliese 370b is located at a distance of 0.26 astronomical units from its parent star and completes an annual rotation in 54.4 Earth days. Thus, the exoplanet is in the habitable zone of its star. If the albedo value of its surface is close to that of the Earth, then the average temperature of the celestial body should be about 25 degrees Celsius, which is a few degrees higher than on our Earth. The fact that an exoplanet is located quite far from its parent star suggests that it is not tidally locked and has its own diurnal cycle. This contributes to an evener distribution of heat over the surface of the celestial body, which as a consequence may create a milder climate. A moderately high gravity should smooth out the planet's terrain, which combined with an abundance of liquid water may cause vast seas to form, both warm and shallow. Such places have traditionally been considered the most comfortable for the genesis and support of life. At the time of its discovery, Gliese 370b was considered one of the most favorable exoplanets for potential biological life. However, more recent research has suggested that conditions on its surface are somewhat less attractive than previously thought. In particular, the atmosphere of the celestial body may be too dense and have a pronounced greenhouse effect. Still, even according to the most pessimistic predictions, the average temperature on the surface of the object does not exceed 78 degrees Celsius, which corresponds to a temperature range of about 30 to 100 degrees Celsius. Given that our planet's climate was about the same during the Archean period, Gliese 370b remains a very promising exoplanet for the search for extraterrestrial life, which means that its exploration must continue. If we stop and look around for a while, we will find that we have already traveled more than 50 light-years away from our solar system. There are over 1,000 stars within its radius, most of them single stars. Others are binary stars or even groups of stars. The most striking example is Castor, a complex and surprising system of as many as 6 components. This stellar system is located 50 light-years away from Earth and is visible to the naked eye as a single source of light. As the second brightest object in the constellation Gemini and the 23rd brightest in the night sky in general, Castor has been known to humans since ancient times. As the system has as many as 6 components, it has a rather complex structure. The 2 brightest of these, Castor A and B, are bluish-white Sirius-like stars, each with a red dwarf companion nearby. The distance between the mass centers of these binaries is about 110 astronomical units, and it takes them 445 years to complete a full orbit. About 600 astronomical units from Castor A and B, there is another compact binary system, consisting of a pair of almost identical red dwarfs. Each has a mass of about 0.6 times that of the Sun and has a surface temperature of about 3,900 Kelvin. The two stars are so close together that they take less than 20 hours to complete a rotation. They move around the system's common mass center following a very oblong elliptical orbit with an orbital period of about 14,000 years. So far, no confirmed exoplanets have been found in the Castor system. But if they do exist, they're most likely to be located here, near the faintest component of the system. In 2018, for example, astronomers detected variations in the orbital period of Castor C, which implies there may be a brown dwarf nearby, about 49 times more massive than Jupiter. According to calculations, it is located 14 astronomical units from the parent star and completes a full orbit around it every 54 years. It is possible that, like many red dwarfs, Castor C has rocky exoplanets close by. In this case, the skyline of such a hypothetical object must present a truly incredible spectacle. On one side, a considerable part of it is occupied by two crimson stars circling the sky without stopping, while on the other side, the eternal twilight is diffused by the light of a pair of stars, either of them hundreds of times brighter than the Earth's moon. Whether this is actually the case cannot yet be verified at this point. Although the stars we have visited are great distances apart, they are all within a single structure stretching for the total of about 300 light-years. This is called the local bubble and contains not only thousands of stars, but also several large structures, including the local interstellar cloud. The local bubble was formed by successive explosions of several supernovae that occurred between 10 and 15 million years ago. It is a giant cloud of interstellar gas heated to 1 million Kelvin. Because of its high temperature, the gas tends to expand, so its density is about 10 times lower than the galactic average. In addition, the hot ionized hydrogen constantly emits X-rays. Fortunately, the magnetic fields of the Sun and the Earth, as well as the atmosphere of the planet, successfully protect us from the harmful radiation. The local bubble is bordered by other similar formations. For example, slightly away from the direction of the solar system's motion is the so-called Bubble 1, formed by supernova explosions in the vicinity of Antares. This giant cosmic structure has been actively interacting with our bubble for a long time, which has caused the formation of tremendous compactions located at the region at the edge. The center of the neighboring bubble is about 500 light-years from us, and the solar system will reach its margins in a few tens of millions of years. Clouds of scorching hot gas and open clusters, giant nebulae and stellar streams. All these majestic cosmic structures add up to a single system called galaxies. In turn, they combine to form galactic filaments, giant streams on walls stretching for billions of light-years. This forms the large-scale structure of the universe, with countless different stars and worlds lurking in its depths. Who knows what we're eventually to find among them? The first steps in theoretical confirmation of there being ocean worlds out there, that is, planets fully covered in water, were made back in the 1970s. That is when evidence was found that radioactive decay in a planet's interior and tidal forces may cause water ice to melt and subsequently form huge oceans. In all likelihood, similar processes take place on Jupiter's and Saturn's satellites. However, these celestial bodies remain icebound as they lie too far away from the Sun, whose rays would otherwise melt the thick layers of ice. But when we talk about an ocean planet, a slightly different type of space object is meant. The term implies that the ocean on a planet's surface isn't concealed under a layer of ice, and its depth measures more than 100 kilometers. Theoretical calculations of these planets' formation and evolution processes were carried out in 2004 by French astrophysicists headed by Christophe Satin. According to this theory, If the mass of a forming planet is more than 10 times that of the Earth, this starts to actively attract hydrogen and helium from the gas and dust cloud around it. In this manner, with time, it grows into a gas giant. By contrast, if this planet's mass is just 6 to 8 Earth masses, the new planet is going to be comprised of ice and rocks roughly in equal measure. Just to compare, the mass total of all water in the global ocean on our Earth accounts for just 0.025% of the Earth's total mass, and whenever some of them are solved, they add to our knowledge about the universe around us. Are we to solve all its mysteries someday? Time will show.